Hello, I hope you're doing well. So this video is for a few of my students who have requested to move a little bit faster than the rest of the group. So I went ahead and prepared something for you to answer the question, why does 45 degrees give the longest range? So in this example, a ball is being struck and it's launching with an initial velocity v naught at an angle theta. Ball travels in the air. This is the highest point. Ball comes back down to the same height from where it took off, goes to flat ground. Gravity is going to be negative g, and there's no air resistance. The dx from this point to this point is going to be called my range. So the first step in solving such a problem is to take the initial velocity and break it up into its x and y components. That's exactly what I've done over here. The v naught, and then I took the v naught x and the v naught y, and I've gone ahead and solved for the initial horizontal velocity and the initial vertical velocity. The other thing you want to keep in mind is when the ball is going up and then comes back down to the same height, it's a symmetrical problem. So whatever the velocity is over here, it's going to be the same velocity over here. By that logic, whatever the horizontal velocity is over here at this point, that's going to be the same horizontal velocity at this point. And whatever the vertical velocity is at the beginning stage, the vertical velocity is going to be the same at the ending stage, except it's going to be pointing down. So let me give you a clear depiction of what I'm talking about, and that's right here. So in step 2, I want you to determine the time the ball spends in the air. And before I can do that, I need to make that realization that the velocities, the horizontal velocities, are going to be identical, the vertical velocities are going to be identical, except the vertical velocity is going to be pointing down. The reason for that is because whatever gravity takes away from you for the first half of the trip, gravity is going to give it right back to you for the second half of the trip. Remember that in this question, there's no air resistance. We're treating it as if the ball is traveling through a vacuum. So for your second step, you have to determine how much time the ball spends in the air. To do that, I just focused on the vertical velocities and the vertical acceleration. I took my kinematics equation, final vertical velocity minus initial vertical velocity over time. I switched the acceleration and the time, and I went ahead and plugged in the final vertical velocity and the initial vertical velocity and the acceleration of gravity, and this is what I came up with for time. This equation will solve for time if the object is released and it lands at the same height from where it took off. Finally, your step 3 to solve this problem is to plug in time into the average velocity equation. Remember, the average velocity equation is average velocity equals displacement over time, and then use a trig identity. And the trig identity we're going to use is the trig identity that's taught to you in math class. Sine 2 theta is the same thing as 2 sine theta cosine theta. All right, now for the average velocity and the displacement, average velocity, the displacement time, the average velocity, if I'm looking for the horizontal displacement, I'm going to use the horizontal velocity. And the horizontal velocity doesn't change, so it can be treated as an average velocity. So the horizontal average velocity equals the displacement dx over t. I went ahead and I multiplied both sides by t and isolated dx. And then when I went ahead and plugged in for time 2 v naught sine theta over g, which we derived in the previous step. Last thing, I'm left with 2 v naught squared sine theta cosine theta over g. So I'm going to use your trig identity from math class that 2 sine theta cosine theta is the same thing as sine 2 theta. And I've simplified the equation to dx equals v naught squared sine 2 theta over g. This equation proves that 45 degrees gives you the longest range, because if you were to put 45 degrees in for theta, 2 times 45 makes it 90 degrees, and sine of 90 gives you 1, which is the largest value you can come up with. So that is the reason why 45 degrees gives you the longest range. This equation will be very helpful, and I hope this derivation was useful to you. If you have any questions, please reach out and let me know. Thank you.